Hi everybody, my name is Kerrie Childress and I teach science with Excelsior Classes. And today's chemistry concept is on measuring density. So you'll just need a few things, a few items. One, of course, is a ruler so that we can measure the volume. Another object that you would need is a scale. And this one I purchased online for about $12. It's a jeweler's scale. But if you have a kitchen scale, that works fine. If it doesn't measure in grams, then you would just convert, and there's converters online that are really easy to use. You'll need some objects to measure. So I have a couple wooden blocks and then a bolt as well. And then the last one is something called a graduated cylinder. And if you don't have one of these in your lab, or at home, they're very easy to purchase online just for a couple dollars. It's a plastic one, but this is perfect. And this is what you need rather than a beaker, because a graduated cylinder actually measures more accurately when wanting to measure a volume of an object. So let's get started. So the first thing we need to remember is to find density, it's mass divided by volume. So I have to measure those two parts, mass and volume. So the first thing I'm going to do is I'm going to take my scale, make sure that it is in grams, and I'm going to measure all of my objects. I'm going to put them on the scale and find their mass. So once that is completed, it's the volume time, and that's a little bit more challenging. But I have my ruler, and remember, you want to use metric, so I'm going to use the centimeter side. So for the square or the cube, very easy to do. Obviously, it's side by side by side, so that you have centimeters cubed. So when I do that, this actually is 27 centimeters cubed, this nice little cube here. Cylinders are a little bit harder, but if you remember from geometry class, you know that it's pi r squared times height. So I'm going to take the radius, I'm going to take the height, put it into my equation, and for this one I actually get 2.51. Sorry, I get the radius of 1.25 times the height of 6. Square the radius times pi, and I get 9.375 centimeters cubed. So those are pretty easy. These are called regular shaped objects. So I can use my ruler to do that. Then I just simply put those values into my calculator to find the information. So for my cube, the final density was 0.53 grams per centimeters cubed. So that was pretty easy. For my cylinder, after taking the measurements and then my calculator, I found 2.51 grams per centimeters cubed. So that's my density of those two wooden objects. The bolt, on the other hand, is a little bit more challenging. It's what we call an irregular shaped object. It would be pretty difficult to find the volume using my simple ruler. So I have another way to do it. It's called the water displacement method, and that is where my graduated cylinder comes into play. So I read my graduated cylinder. I have enough water in there. I have 78 milliliters, and so that becomes my initial volume. When I very carefully slide my bolt into my water, it's going to change the volume because the bolt has now displaced water, and now I have a new volume. So when I read the new volume of 79, I know that my the volume is 1 milliliter. Then I put it on my scale to get the mass, and I find out that I have a density of 9.7 grams per milliliter for the bolt. So those are two methods. One is regularly shaped objects using a ruler and a scale. The other is called the water displacement method for my irregular shaped objects. So I use the volume change for volume and then my scale to find the mass. Now, one thing you can do and it's as an extension of this lab, is you can find out what your objects are made of. So what kind of wood would these be made of? I can use the density as an identification factor. I can also do the same thing with this bolt. If I know what the material is, I could also do a % error to find out how close I came to the actual density of the material that I'm testing. So those are a couple extensions that you can do from a simple density calculation and a density measurement. Thank you for watching.